Okay, so we're recording again. So we're recapping the page 4 and page 5 of the section 4.4 notes. So for example 11, at what point in the graph of y equals 2 to x minus 5 is the tangent line perpendicular to the line y equals -1/3 x plus 2? Well, if you're perpendicular to some line, then means your slope is going to be the negative reciprocal. So reciprocal of the line we're perpendicular to is -1/3, so the negative reciprocal is +3. So then what you have to do is you have to take your derivative of the function, because remember the derivative of the function is represents the slope of the tangent line, and set it equal to 3. So by doing that, we do know that the derivative of this is going to be 2 to the x times natural log of 2, and then of course minus 0, because derivative of 5 is 0. So you got that set equal to 3. Divide by natural log of 2. And yeah, then when you want to isolate x, and you should be able to be pretty comfortable isolating x using the properties of logs, but we have to review that from worksheet 16. So we have this over here. When you divide by ln2, you can write as x equals log base 2 of all that junk. Use a calculator, get 2.13. Plug that into here, and I talked about how you might want to store it so you get a more accurate answer. And that would be the point where your tangent to the line perpendicular to that line. That's it. So that should be pretty straightforward there. Example 12 is somewhat relevant to what we're doing right now. Hold on 1 second here. Okay, sorry about that. Just have to. Okay. So yeah, so here we have the spread of the flu, and we have an equation. This is called a logistic function. And you might have covered that in pre-cal. Hopefully, it was covered before we went through remote learning. If you did, hopefully it was still covered. And it's just an exponential function. That's all it is. And graphically, it looks like this. We have a y-intercept. If you plug in 0, actually, you could get the y-intercept, which we did in part A. The initial number was 1. And it does rise exponentially until you get to like kind of a threshold. And actually, the threshold is going to be at 400. In fact, we call that the limiting factor because you can only infect so many people at the boarding school. I mean, we assume this is a isolated area, maybe somewhere beautiful on the East Coast, perched high up in a hill. There's only so many people we can infect, and of course, we were assuming that they're not other people that are coming to the campus, or these people are going home and getting sick, and then it's just people within that bubble that are potentially infecting each other. So eventually, it has to slow down. And that's kind of what we're seeing like right now in our community with the coronavirus. Like, yeah, I mean, there's only so many people who could get sick, right? I mean, of course, we want to slow the spread, but at a certain point we reach like they call it herd immunity, right? Like we get to a saturation point. So part B is just evaluating how many people get sick after 1, 3, or 6 days, and then C is how fast the flu is spreading. Obviously, this is a derivative, and you're asked how fast, so that's what we have to consider. And so you simply take the derivative of this right here, and you could use your calculator if you want to, but if you treat it like a chain rule where you do 400, or you do quotient rule, I don't really care. But you move the -1 to the front, check the derivative of the inside, and then of course plug in the values 3 and 6. And you get this down here. And that's how fast the derivative is moving. So basically on day 3, like maybe day 3 is over here somewhere, we see that it's rising pretty quickly. And we could say that there's 18 people per day on average, not average, but instantaneously, there are 18 people getting sick per day on day 3. So maybe the next day we expect 18 more people to get sick. But on day 6, now the derivative's up to 100. And day 6, remember, half the school is already sick. So now all of a sudden we're saying, wow, 100 people per day are now getting sick as a rate. So that's what that's all about. And this might be kind of a great free response question to do on our small test next week on the 17th. And then lastly, I just talked about the proof of e to the x and how to actually work that out. Analytically, y is just e to the x. We have to use some properties of exponents and of course use this limit property right here. And then that's how so I'll just e to the x analytically. But of course, graphically, we saw that in the beginning of these notes here. Okay, so now let's move on to this worksheet. Let me go over that with you guys, and then I will have you guys ask questions about the textbook problems. So this right here, I don't have it worked out yet, so I'm gonna actually work it out from scratch. Probably better that way anyway. So remember, there's a general rule we go about this. What I suggest that you do is make a little table. Here's f, here's f inverse. Find the coordinates of f and find the coordinates of the inverse. Well, you're told that f is 0 equals -7. So 0, -7 are points on the original. Hence, -7, 0 are points on the inverse, right? You switch x and y. So that should be pretty straightforward. Then this is the main rule here. F prime is 0 equals 1 over derivative inverse of -7, right? And if you think about it, f prime of x is pretty easy. That's just 7x6 plus 5x4 plus 11. And again, this is the main rule here. The derivative of the original is the reciprocal of the derivative of the inverse, but you have to use the inputs. That's why I do this little table. You have to use the inputs that are associated with each of those functions. 0 is the input for f, hence -7 is the input for the inverse. And again, the derivative of the original is the reciprocal derivative of the inverse, evaluated at their proper x coordinates. To find f prime of 0, that's easy. We already found f prime of x, plug in 0 into that derivative, and you get 11. Hence, 11 equals 1 over the derivative of the inverse at -7. Right? Easy enough. So that's 1/11. And that's the answer for number 1. Any questions about number 1? You can put in the chat if anything was confusing or need me to re-explain something again. Okay. Let's keep moving. Example 2. Now here you're given a table. You may not necessarily have to use all the information in the table. Likewise with number 3, you're given a bunch of values like g of 5, g of -2. You may not necessarily use all those values here. Those are more AP style problems because you really want to see if you can discern what you need to know and not need to know. Now here, you're asked to evaluate this inverse at 3, the derivative of the inverse at 3. So make a little table. So this is going to be just the y coordinate on the original. Remember, it's an inverse, right? So whatever is in the input for the inverse is the output for the original. So this is going to be the y coordinate on the original. So that's comma 3 So that's 3 comma. Remember, this is x on the inverse for 3, but it's y on the original. Now, because this is y in the original, I look for y. Here's f of x. When y is 3, the x value that goes with it is 5. So I put a 5 here, and I put a 5 there. So again, this is x on the inverse was right there, 3. So that's y in the original. According to the table, y is 3, x is 5. Therefore, 5 comma 3 is on the original, 3 comma 5 is on the inverse. Hence, f prime of 5 equals 1 over derivative of the inverse at 3. And f prime of 5, you can find also f prime of 5 is -7. And now you can find the derivative of the inverse evaluated at 3, and that's going to be -1/7. So you can just flip over both sides. That's totally fine to do. And there you go. -1/7. Hopefully that's easy. That's number 2. Any questions about number 2? Okay, let's keep moving. Okay, over here, what do we got? So you want to write the equation line tangent to this. Now, here you're told g is the inverse. So that's kind of nice. You don't have to write f -1. You can write just g. So we'll do f, and we'll do g. And here, you're trying to find the equation line tangent to g of x at x equals 5. So the slope of our tangent line is going to be g prime 5. Or, the derivative of the inverse of f at 5. Same thing, because the derivative inverse of f is the same thing as g. We're told that, right? So I need to figure that out. So this is going to be, remember, that's going to be the y coordinate on the original. So the x coordinate inverse is 5. So y coordinate in the original is 5. Now, we're also told that for the inverse, g of 5 is -2. So the y coordinate for the inverse when x is 5 is -2. Hence, -2 is the x coordinate on the original. So this is the y on the original. That's going to be x on the original. Remember, it's all reversed. So f prime of -2, right, equals 1 over g of 5, or, the derivative of the inverse at 5. G prime 5, so I have to say. And that's what we need. We need g prime 5. We need this. Well, we know f prime -2 is given to us as 3/4. So far I've used this, and I need this. So g prime 5 is 4/3. Okay, remember that's the equation of a line. Your slope is going to be 4/3, x minus 5, and y minus -2, or y plus 2. So notice I did not need to know this or this. Those are actually there to throw you off a little bit. So you have to really keep things organized by kind of doing this part right here, knowing the coordinates for both the original and inverse, and then using this rule or property that we've talked about, and just working out the rest of the problem. So any questions about number 3? Okay, let's keep moving. Oh, question in the chat. How do I get the slope again? Oh, well, remember, slope is derivative, right? So you want the equation line tangent to g, so you need g prime, right? Remember, we know that. And how do I get g prime of 5? Well, before I worry about that, I know that I'm dealing with x equals 5, and we are told that when x equals 5 on the inverse, the y value in the inverse is -2. Hence, you have -2,5 in the original. Then you have to use this where you see the star here to make that connection between the derivative of the original and the derivative of the inverse. And we do see that, oh, g prime 5 helps us get that slope. In order to get that, I have to evaluate f prime -2, which of course is given to me as 3/4. And then I just flip it to get 4/3. So that's how I get the slope of the tangent line. I basically flip this over because that is a reciprocal of g prime 5. And again, very important that you know what your x and y values are on the original and inverse. So yeah. Okay, I'm gonna go and clear screen. And this part, maybe we could do that on Thursday. We won't worry about that part for now. I didn't go over this with the other class, but maybe we could have that discussion because I do want to keep things moving here. Okay, so now, what questions do you guys have about the textbook problems? So feel free to fire away and ask questions. Oh, let me show the answers first. Maybe I'll do that. That's probably a better thing I should have done. Sorry about that. Here are the answers. I mean, it's odds. You have the back of the book, but so questions. Any of these likely to work out? No, we're okay. You guys got them all? Let me quickly go over 13, just in case if there are any questions about that. Remember the derivative of a to the x. I'm going to actually do the analytical part for you guys so you see how that looks. It's just going to be a to the x times natural log of a, right? So that's exactly what I'm doing here. It's 3 cosecant, you keep it intact, whatever the exponent is, times natural log of 3. But then you got to do a chain rule, the derivative of cosecant x. And the derivative of cosecant, this is where the cheat sheet is your best friend. And there's a question in the chat, I'll get to that in a second. Derivative cosecant's right there. So, obviously you want to be very comfortable with that. And derivative cosecant is going to be 3 cosecant x times natural log of 3 times negative cosecant x times cotangent x. So there we go. That's that one. Question in the chat. Number 9. Oh, that's a good one. Okay, let's look at number 9. For number 9, you have e to the root x, so that's going to be a chain rule. So the derivative is going to be e to what you see there, e to the root x itself. And you could do natural log e if you wanted to, but it's kind of redundant because that's 1 anyway, so you don't need to waste your time doing that. But anything that's not base e, obviously you got to do ln of that number, and then derivative root x. Okay. Well, that's e to the root x times 1 over 2 root x. Now, in case you forgot, root x is x to the half power. We know this. When you take that derivative, you get 1/2 times x to the negative half, which is 1 over 2 root x. And that's that. That's what you see right there. They actually are really sloppy with how they wrote that, by the way. It really should be written like this. It should be e to the root x, and the whole thing is divided by 2 root x. That almost looks like it's e times root x. Yeah, that's written in a very sloppy fashion, just so you know. Should have actually discussed with my A period, but at least I'm recording this. That's what it really should be. So if you got this, you're fine. I think it was just really sloppy the way they typed that up. So that's number 9. Anything else you want to go over before we hit up the 4-4, wrapping up the 4-4 notes? Excuse me. Okay. If you have anything else, just ask during the break or during lunch if you want to, or if I end class early, you could always ask too. So let me stop sharing that and stop that recording.